and I'm really thankful for this invitation because Harshi sir is called me about this conference. So I'm really grateful as the sir explained about me about I'm the first batch student in SIT. So it's one of the good moment for me also. So let's begin with the topic which I chosen, EMC techniques and control measures. So today I'm focusing on the overview, introduction, and the types of EMC in some examples, and design for the compliance, design for the product development, prevention, and mitigation techniques, testing and control of control measures of the EMC, and some standards and regulations, and just an overall summary. So, what is EMC? So, as we know that everybody know about the electromagnetic interference, but some point we need to we need to standardize the electromagnetic interference when we are working in the different industries like in the military or product development and product based company. We should be more careful for while doing these EMC designs. So some point we need to control the EMC EMI emission. And also we know that nowadays power electronics are more advanced techniques we are using in the different industries, especially in the automotive and aerospace, and a lot of industries are still using the power electronics. And now every day by day and also year by year we are developing the new electronic devices and also the integrated circuits. So this interference always come under this picture because it's going to be crucial role in the product development. So EMC study how the various of device interact and how to ensure that the device plays nicely together when they are in the same area of the same network. So as I explained before, the electromagnetic interference is a disturbance that affect an electrical circuits caused by the different switching devices, different power electronic devices, and also the different antennas come under the picture. And also this will be become more more cases in the product development stage. So we can just categorize EMC is two types, emission and immunity or susceptibility. And also we can divide it in the two types of emission is a conducted one and a radiated one. And also the same way the conducted immunity and radiated immunity. We can go in depth in the following slides. So as we know that the emission is some body is emitting the radiation in form of waves or heat or different form of radiation we can see in the daily life. So this is one, the electromagnetism, also electromagnetic interference is also the emission which we can see in the different electrical and electronic circuits. And the susceptibility is controlling how the susceptible the device during the phase of electromagnetic interference emitted from some other devices. So the causes of the EMC is two way. One is the emission from the same devices, and also the particular devices is susceptible from the emission AMI emitted from some other devices. So these two way we need to find the causes, and also we need to control this emission. And just for the clarification about the EMI and EMC. So EMI, as we know, and I just discussed the interference, so electromagnetic interference. While each electrical and electronic circuit produced depends on the which components are inside the product or inside the material. There will be some emission, we can say, while For simple example, we can see just a current passes through the cable. There will be some radiation we can find. So we can easily analyze even even from the cable. So the same way in the every circuits we can find or we can analyze the interference. And EMC is how effectively we can control the EMI. So EMC is a we are keeping standardizing standardizing with some regulations to reduce the EMI, and also we can avoid the EMI interference with some other devices and also the same device. So as I explained earlier, the radiated EMI and the conducted EMI, the type of EMIs. So the same way, the radiated means we can see the device radiated to the atmosphere around it, and also same like the microwave or walkie-talkie, and same like even the antennas and any kind of device we can see. A simple example, we can say even the TV or telephone also for the radiated emission, we can say. Also conducted emission always through the conductive power connectors or the cables. For we can categorize mainly the signals and power cables. So the both will be act an important role in the EMI. So just an overview, like as I explained earlier, the conducted EMI, conducted emission and radiated emission, and also conducted susceptibility and radiated susceptibility. So it will be, for example, in this section, the conducted emission should be the radiation emit through the conductors, and the susceptibility, the same cable or same conductive disturbance from some other network. So it will be connected to the some other switching devices or some other power electronic device. So there will be a chance of radiation from the cable, and also radiated emission the same way. The same component will emit the radiation, and also it will be radiated by some other devices. So these are the main causes of and also the way of emissions, and we need to we are checking now how we can control the EMI in the product development, and also in um, also to regulate, and also for the big example, like if you are doing some free trade to the different country, we always need to comply with the regulation of the different country regulations. So we have to check how the host how the other countries and how they are regulated to the EMI, and we can check in the following slide the different regulations in the world. So as I explained earlier, the main causes is the switching circuits and a natural field, and also I can give some example of the natural field also later, and also some electrical field radiated from the current, and some coupling of electrical field into the circuits and components, and also unintentional and intentional. So maybe intentionally radiated devices causes the EMI, and also unintentionally it will affect. And also some effect like the causes of the problem of electronics. So the same devices, maybe the frequency or switching device or switching the time or delay in each application, and also the loss and distribution of data. So we can sometime we will lose some important data. So for a big example, we can say for the military application, so they are using the separate frequency range to the communication also, but sometime this will affect the big data loss from for the country's secret code or like that. So in that case also we have to be careful for while designing the each circuits, how we can able to avoid this kind of interference from other devices, and also from the same devices. So just an example, like intentional emitters like a mobile phone, wireless LAN and remote controller, and also the same way, um, radio and TV receivers, mobile phone, wireless and remote control devices. Like these, we can say the intentional emitters and also the receptors. So, just a big example we can see in our. But nowadays, these issues are resolved most of countries and most of devices. Big example, while we are keeping the phone near to the TV. I think in the old versions now, I think it's everything is mostly is regulated, and also it's a controlled EMI regulation. So if you keep the mobile and while it's running, there will be a flickering in the display. So that means that there will be the interference between the two signals. So that is a big example I can able to say about this EMI. And also in the also the interference we can say like in switching and digital circuits and auto ignition, and also the electrostatic discharge, and also the lightning, it will affect for the uh, uh, unintentional emitters. And also the same way the telephone and audiovisual analog and digital circuit, it will affect very easily due to the interference of some other devices. So uh, in here we can see one circuit is connected to the power and signal cables, and the source of equipment emit the radiation, and also this we can see the radiation, and radiation chases to the chases, and also the external peripheral, and also it will connect it to the another cable, so there will be a chance of emission of the radiation, and this is an external input, so it maybe it will be affected this cable signals also. If it is a signal cable and this is a power cable, there will be some distortion or data loss in the signal cable. So maybe we will not get exact the result what we are expecting from the external input or output. Okay, so the same way, um, inter-system EMC, the source and victim are the two different pieces of equipment. The same source will emit the radiation in form of EMI, and also it will affected by the some other devices also. In the same way, the power lines and the signal lines, there will be the distortion will occur from these devices also. So some like as I explained earlier about some power electronic devices is one of the major cause of EMI emissions, and also the radio frequency interference. As we know that the different stations and different, and also some they already set up some frequency range to avoid, and also we can able to choose the proper way of signal absorption, and also we need to avoid from other signal, and also it will interrupt and interact with the same signal, so it may be affect again with the EMC. And this is another one example of the magnetic electromagnetic pulse, the intense surge we can say, uh, for example even the lightning or this kind of intense it's a sudden peak of radiation in form of a high energy. Um, it will affect a lot of devices. So we can say it is also like unintentional. So it is a natural or maybe intentional way. So it will affect a lot of electronic device. So also we need to avoid this kind of emissions, and it will not make sure it will not affect to the other devices also. So some major aspects on in the design phase. Initially we have to check how many layers of PCB, and also input and output ports. We sometimes we can see some PCBs, not in some PCB, most of PCBs are they are keeping away the input output and digital and analog inputs apart from each other because of this to avoid this signal distortion. And also input output ports isolated or shielded, or which kind of IC family, and how well it is shielded. And also we need to check um, the coupling capacity of the PCB also. So while we designing, we need to check even the each trace, how we need to manage even the each trace in the design phase itself. So even in the design for compliance, also initially design must be careful for while designing how, what is our goal, and what is an output we are going to achieve, and the components which we need to choose, and how we need to, how these components will affect to the our application, and also it will be affected the other devices. PCB architecture, obviously what I explained before, same like PCB layout and in IO ports. Also the cables. Cable also one of the major important roles in the conductive emissions. Also shielding and software and firmware. So in EMC, in product development, which I'm currently working through, and we are always checking how well compliant with EMC in the different products, and also the different standards, and where we are um, moving, or where we are exporting or importing these products. So typically, the product development phases are initially we need to set before the um, final final manufacturing time. We need to define the product specification and system architecture, how well is physically designed, and the product quality and qualifications. Correspondingly, EMC requirement analysis and EMC concept and review, EMC review, design and review, and EMC lesson and learn, how well we need to learn and how well we need to organize these topics also. So in specification phase, we need to check whether the EMC is required. EMC is whether is required for this product. That is the first thing we need to check, and also which directive, which compliance regulation we need to obey. So ensure the standards and understand where we are using this device, and also the country codes, and also where and what is we are implementing, an architectural design, and the purpose of preliminary EMC design concept, creates the EMC test plan, and the purpose of PCB design strategy, and the review power stage concept of EMC, and detailed design, implement the strategy and concept of do pre-scanning test and simulations, prototype and qualification, do formal certification testing, redesign and retest, and failure here are expensive. So in overall in the product development stage, in any kind of product, even in automotive or in the refrigeration or any kind of products, we are like in the manufacturing firms. So all these phases are involved in the design phases. So initially, they start with the design review, and the design review depends on the company regulation. They will do the design review 1 2 3 different test plans they will do, and before so the manufacturing trial, pilot production, and final manufacturing trial, and finally they will do the mass production. So before the final manufacturing process, especially in the manufacturing trial and pilot production, always checking how well it is compliance. I'm telling about only the EMC topic. So anyway, we have to check in the different aspects anyway in the design point of view. So EMC is one of the design aspects in the early stage of design. So initially, always checking. Some companies always keeping some EMC test rooms to avoid the failure of test result. So some companies cannot afford because the test room is very expensive. So they have to test in the authorized the test center. Depends on the company and products, and depends on how and where they are using these products. So these all are under consideration uh, while producing the each products. So this is just a basic idea about how the usage of EMC in different product development. And here the point is a failure here are more expensive. So that means, for example, we can say if the product is testing at the end of manufacture, fine, end of the mass production, like they produce like thousands or maybe 10,000 of units. So at the end, they are trying to test to validate the product, but the test is failure means they are losing the labor cost and the components and lot of effort until the mass production. So initial phase itself, like in the most of companies who care about these standards, they are taking care of from the starting phase, and they will try to standardize their product. So if they are facing any issues during in the test phase, they will change the components in the early stage itself to avoid this uh, extensive expenditure at the end of the project. So I'm just given some product development idea how it will be work in the different company aspects. So mitigation software and the techniques. EMI analyst is a tool used to meeting the EMI requirements at a regulatory agency. So yeah, as we know that the different standards we are using in the different industries, and depends on where we are using in where we are using the products. For a big example, um, so we already like in the European standards we know, and also the American standards. So one example, these most probably we can say that these products, these standardized product, we can able to use it in India. So according to the regulation of our country, probably it will meet, depends on our standards. But while we are producing from our country or our production site, so we have to compliance with their standards. So we cannot say the American standard is equal to the European standard, or in Japan or China. So that is a different scenario we have to follow for the product standard anyway. And also we have to check in the all the four EMI areas: conducted and radiated emissions, and also conducted and radiated susceptibility from some other devices. So it will be use of like a big money saving in the initial, and also the reduction of the circuit design area. So if you make the effort in the initial stage, it will be affect even the money saving tool also in the design phase. So now I'm just giving a brief idea about the test procedure, because the test setup, as I told you earlier, it become very expensive, and the big companies are making some test rooms in their laboratory, but it's not, and also they cannot completely completely obey or completely believe from their test results. So they have to go with the one authorized test centers to standardize their product also. Maybe in this way, if some companies have their own test room, they can test and validate the products in the same time products, and also at the same time they can test just a final test in the authorized test center to make a test certification. So this should be a more convenient for the big companies, but the small companies cannot afford the test room, so because of the high cost of setup, and the components are really expensive also, and they have to meet all the test room standard also. So test procedure, I'm just categorizing the two way only, the radiated emission and conducted emission. That we can see that EMA is mainly categorized the two way. So in the radiated emissions test setup, there will be the two type of test setup. This should be open area test site and closed area test site. closed area, we can categorize the semi-anechoic chamber or anechoic chamber. This, so we can see in the picture, the first picture we can see this is an open type test setup. So we can see one antenna is here. This is a, so they will place a product here. Normally in the open type, they will keep typically 3 mm to 30 mm, depends upon the antenna or depends upon the types of measurements and the strength of the field and strength of the emission of the field from the same device. And also in the mostly the conventional type, they set up like a closed type semi-anechoic chamber. So in this case, it will be become like a 1 to 4 meter, and also the turnable, um, uh, turnable. The device should be placed here, and they can able to turn around 360, and they are checking whether all the uh, emission from the all sides. So they will place the antenna here, and they can check it and also test it. And I just explained before, like anechoic chamber and semi-anechoic chamber. So it is like it is a shielded metal room, and also it will help to attenuate the background, like background ambient radio signals. So just um, we can explain like in this chamber there is no all this spongy type or peak type of material. It is like absorbing the signal. There is no reflection. So for example, if this device checking when it is power on, so maximum the EMI radiation will be um, measured from this antenna, and there is no reflection from the ceiling or wall. So anechoic and semi-anechoic chamber difference is in the floor. They are keeping the metal or reflective place in the semi-anechoic chamber. So that is a common standard of EMC test room. So in anechoic chamber, they are making the uh, complete protective, like absorbed material, which cannot reflect any radiation from even from the floor also. So these are the two type of test setup, like in open type and closed type. The closed type against semi-anechoic and anechoic. And in anechoic, mostly in the complete electromagnetic magnetic measurements, and also acoustic measurements, they are checking from the anechoic chamber, because they have to make sure there is no loss or there is no interference from the other devices. So that's why that kind of test setup they are making for the making for acoustic and electromagnetic testing. So for the EMC, mostly we are using the semi-anechoic chamber, and also the measuring antennas. So different kind of antennas we are using for the measuring. That is a loop, bioconical, low periodic, and horn. Why? Because it depends on the different frequency range. Mostly in the radiated emission test setup, the frequency range should be the 30 megahertz to 1 gigahertz. This is a normal standard test setup. And also maybe some product, it will be more up to higher gigahertz, depends on the product, and also depends on the standard they are using. And also the different antennas have the different gain profile across the different frequency ranges. Ideally, you want a high flat gain response across your measurement band of interest. And also, without reasonable amount of gain, the measurement signal fed into the spectrum analyzer or the EMI receiver. So we have to check how much is the gain, and also whether we can able to catch the appropriate signal from the antenna also. So that's why we have to keep the proper setup for the each frequency range, and we are keeping the different frequency range and different antennas for the test setup of radiated emission. And about the conducted emission, the device create the magnetic energy, and the certain portion of it will be conducted into the power supply. And this lab test measurements approximately like the standard will be like 150 kilohertz to 30 megahertz. So this is a standard limit of a conducted emission frequency range. So this help to ensure to the local power supply remain relatively clean, so we can avoid some um, uninterrupted power supplies to avoid these frequency range disturbance anyway. This is a test setup of conductive emission. So there is some device. This is a line impedance stabilizing network, which we are using here to stabilize even the network. This is a uh, equipment under test, and there should be some electrostatic discharge probe we are using to create some impulse to the products, and checking through the line impedance stabilization network, and it will receive the signals to the spectrum analyze to check whether what is main causes, and also the emission will be under control or over control. So this is a one way to the test setup. So mostly we are using the AC power supply, and also some device, or depends on the standard they are using, they are checking even in the DC power supply also. And yeah, so as I explained, the EMI receiver or spectrum analyzer, after this we are keeping here, and the ground plane always keeping the device under test, and the spectrum analyzer device under test, spectrum analyzer, and also line impedance stabilization network. These are these two types of test setup commonly used for the EMC standardizing components, especially the conductor emission and the radiator emission. And the frequency range, as I explained earlier, 150 kilohertz to the 30 megahertz. Maybe slight lower or higher also we can use, but higher anyway we will not use for the conductive emissions, because maybe it will be distortion may happen to the signal. So mostly the range should be here, and also almost all the countries are following to the same range also. So now we can check how and which components, which control measures or countermeasure we can able to reduce or prevent. We cannot avoid completely, but we can able to control the emission in a certain period. That's why they are setting some parameters to make some range of emission categories. So the big example is EMI filters we can use, and also we know the chalk a coil of wire wound around the magnetic core, which can be block even the high frequency in AC circuits. And also we can see that the big example we can say in some cable like HDMI cable, we can see there will be some ferrite. Uh, I can see here. This should be ferrite is act as a low pass filter, so it will pass through, allowing the low frequency signal to pass through while absorbing and dissipating the high frequency noise. So this ferrite will also help to reduce the emission through the conductive emission. Conductive emission can reduce even from the ferrite material. So this is also one we can able to see very in the daily life. We can see this one of the example And while designing phase, we can able to check whether the power network and also the signal network where we can use these kind of devices or these kind of things. And also another material like the surge protector also can able to avoid from the high surge in the circuits. And also maybe this depends on the power supply, we can able to introduce the surge protector also in the particular component, but that is also other costly control measures. So the initial phase also we can able to check how we can control even these control measures. So electromagnetic shielding. So as we know that the enclosure formed by the conducting material and isolated electrical devices blocks the external electrical field. So only if you keep, sorry, if you keep the sorry, yeah, if you keep like a Faraday cage or in the um, enclosed cage, we can avoid even the electromagnetic shielding also. So also for the big example, for the cable we can see the different core and different dielectric material. So depends for the application, especially in the signal cable we can see the high insulated material and also high shielding we can see in the outermost shell. And also even sometime we can see some oil or some different insulating material to avoid even this kind of interactions. Uh, how I can shield my devices from the EMI. So we can check quickly how it will come. One is a natural EMI shielding. We can say like we can made material electrically conductive material that absorb all the radio waves. EMI shielding system. EMI resistance such as design must be employ the methods such as adding the coat of EMI shielding paint or gasket, shielding cable, different kind, and the ground. We have to well design and the low impedance grounding system should be implemented in this kind of devices, preventing EMI generation. So so we can reduce the influence of EMI prevent from being generated and also generated from other devices. And the big example of like a wire junction box, we can avoid the crossing of signal and power cable, so we can separate even the boards. And power conditioning, these devices such as the power line filters like surge protector and also ferrite, these also can be reduced even this EMI. So the final things we can able to go ahead with the compatibility, how well we need to combat with these EMI regulations. So we have to check from the low level like a house requirement, regulatory requirement, special requirement like a military standards, regulatory requirement like trade, free trade in the different countries, sales, and house is functionality, reliability, and the self-imposed design. The houses are normally the less complaints because they are not because it's completely for the commercial applications and also the residential application. And why we need the EMC regulations, protect the environment, market force, international trade like free trade, as I explained earlier, the safeguard to the customer to avoid the product and also the signal or power loss from the same device or affected by some other devices also. So some major EMC standard, we can see the European standard, the CE label, and also United States FCC and Australian standards. And the different countries have different standards. So most probably we can see the IEC and CE and EN, ISO and FCC, CISPR. This kind of different standard we can see, and other countries are still implementing. And also some countries like Russia, Japan, or China have their own standard. But if they want to do the free trade with the different country, they have to obey and also combined with the different standard level also. So these are the FCC CSPR is just a example in the United States. They are following these standards, and they're just categorized the two types: the Class A and Class B. Class A for industrial and commercial applications. Class B, they are focused in the residential purpose. So exclusive the device which is marketed used by general public, which is intended to be used the some devices also they are depends on the device they are keeping the class A even in the commercial in the residential application. This is just an quick example of class A and class B graph. We can see the different way, because in the class B the band start from the 29.5 volt per meter, and also the FCC start from the 30 the same frequency. But in the class A there will be some higher, because in the class A always keep before the industrial and commercial applications, so they have to attain the high level of standards. Class B in the residential purpose, though they are keeping the less. And other as I explained earlier, like ECE and FCC, these are the different kind of C is the European standards, and these are the type of standard using right now. And we can see for the big example of IEC, and we can say some for some coincidence like the IEC and EN using the 61000, same kind of standard. But because IEC, International Electrotechnical Council, also um, these standard also similar to the EN and also CE standard. So we cannot say it is equal, but some point, or we can see here they are implemented very long back, and this kind of standard, and every year they are doing the, not every year, but it depends on in the new revision they are changing, depends on the component and product level. The standard is varying and changing. And yeah, so just as 2 is equal to like IEC 61000. So these are the some EMC emission standards. Basically, IEC or EN or CE 61000 is a standard category of EMC, and it will categorize in the different way, like emission and immunity, and also the different category: light load, power load, like microwave and TV receiver, and they are keeping the different level of standards they are using for this also. The same way, the immunity, susceptible standard also same, like they are keeping the different standard level, and they are trying to attain the same compliance standard. And yeah, I'm just I know it is a big topic, and I cannot include the many things because of a lot of things. And just concluding uh, my topics anyway quickly, because we already discussed about the types of EMC and how, and the different types and the prevention method and some control measures and some test setup and laws and regulations. Yeah, that's it. Any questions?
Hello, sir. Sir, thank you so
Yep.
much. Any questions from the audience? Sir, any questions from the audience? Hello.
Yeah, I know
I
this
think,
topic is a little bit wide, and it's a little bit a big topic. I couldn't involve the many things, but still, if anybody have some doubt, I can able to
okay.
clarify.
Okay, sir. Sir, thank you so much for sharing your valuable insights of electromagnetic interference devices and EMC standards. Sir, really, we have got the knowledge about this information, and thank you so much, sir.
Yeah, I'm also really glad. Anyway, the Harshit sir and Logesh sir, and I know they are. I'm the first batch of students, so I know I'm also a little bit. proud to present in front of the students. Anyway, I couldn't get much time to prepare, but it's very quickly I made, and also I prepared some documents for my company, so I made it yesterday quickly. And if you have some time to interact in the university, or if I get some time, and also if anybody have some doubt or anything regarding this topic, you can contact me and Harshit sir and Logesh sir have my contact, so we can discuss further also.
Okay, sir. Oh, sir, once again, I'll conclude with the gratitude to you, sir. Thank you, sir.
Yeah, yeah. Thank you so much. Yeah, thank you.
So after this, we'll have a quick break, and after that, one or two sessions will be there, presentations will be there, and then we'll have the validatory function. Okay. So please have a tea break and come back. Okay.